Welcome to Security Weekly Unlocked and this sponsored demo by Accurix. I am your moderator, Matt Alderman, formerly the CEO at Security Weekly and now Executive Director at Cyber Risk Alliance. Joining me is Om Mulchandani from Accurix to discuss and demo policy, remediation, and drift as code across your design, build, and runtime environments. Om, welcome.
Thank you, Matt. Appreciate for having me.
So I want to start with talking about infrastructure as code, because I think it's an interesting concept that a lot of people don't think about in the application development world. This infrastructure as code is used to spin up the infrastructure that your application is going to run on. A lot of people focus on, source code or software composition analysis. Your unique spin here is looking at the infrastructure. What are some of the challenges around looking at infrastructure as code?
So, Matt, infrastructure as code is a hyper automation technology which allows you to automate provisioning, deployment, and management processes for your cloud infrastructure. And it also enables you to push immutable strategy within your cloud infrastructure. So, of course, the idea is that you want to use infrastructure as code as a single source of truth for making your changes as well as for provisioning processes, right? But that's not the reality. A lot of times you would have break the glass scenarios, you would have emergency situations in which you will have to go and make direct changes into your cloud environment, and you'll have to kind of forget infrastructure as code for a second. But that's when your infrastructure as code and your runtime environment is not in sync, and the drifts are caused. Now, these drifts can be really costly from security point of view. They introduce risks. So these drifts have to be identified. That is one. But then infrastructure as code also presents a big opportunity, which is it contains a lot of interesting data. It contains very rich data, which can actually help you analyze security posture of your cloud infrastructure even before the cloud is created. And that's where we come in. So you could analyze infrastructure as code, and the technology that is enabling such analysis is policy as code, and which results in your posture assessment, your posture analysis, and then your drift as code is going to help you determine the drifts. But we go above and beyond that. Not only we determine your compliance levels, your assurances across your cloud infrastructure, looking into infrastructure as code, but we also go one step forward, and we also offer remediation as code, because remediating problems at the design time presents you with the lowest cost of remediation, right? The cost keeps on increasing as you move forward in the life cycle. When you go to runtime, the cost of remediation is the highest. So these are some of the benefits that come out of the infrastructure as code.
Yeah, and a lot of people that went after the space early on kind of did it in the runtime environment. We think of the posture management, cloud security posture management vendors, right? They were looking at the configuration of your cloud infrastructure after it was already spun up. What you're talking about is analyzing the templates that spin up the infrastructure before you spin it up to actually allow you to look for potential gaps in your configuration or your policy before it's running, which is an interesting take because you can find issues before you actually deploy the infrastructure.
Right, and that's very, very powerful. When you are able to determine security gaps, your best practices gaps, your standards and compliance gaps ahead of time, you have an opportunity to address them in a way which is going to help your developers, cloud developers, as well as your security teams. Having said so, infrastructure as code is so rich now, especially since the technology has evolved in the last 5 years, that you not only can detect your misconfigurations, but now the opportunities exist where you can also detect breach paths. You can actually detect what kind of attacker capabilities you are introducing in your infrastructure. By analyzing infrastructure as code, you can determine what kind of attacker phases are possible to be pulled off. And when you contextualize your security gaps, mapping them to attacker capabilities, you are able to help your security teams as well as your development teams to prioritize the remediations. You know what's coming your way, you'll be able to fix them better then.
Yeah, what a way to visualize your and do your threat modeling through that visual interface, right? Because a lot of people use tabletop exercises to understand the threat models, right? And the potential attack paths. You guys actually visualize that. So I think what we should do is actually show it instead of stop and not talk about it anymore.
Absolutely, absolutely. All right. Just to level set, a couple of slides, and then we'll jump right into the demo, right? So um, the first slide is about what is immutable infrastructure. A lot of folks have different meaning about it. So just to level set, now the modern cloud infrastructures which are built to host applications which are designed with cloud native technologies in mind and immutable technologies like containers in mind, service mesh in mind, such infrastructures are layered in nature. And you will see that such infrastructures will have at least 2 or 3 different layers. So there could be a bottom layer, which is usually provisioned and provided by public cloud providers. Of course, there are on-premise options available too, but providers like AWS, Azure, GCP, they provide this layer which allows you to provision your networking, your storage, your compute layers. But then it also comes with its own set of APIs. And these APIs are pretty powerful. Otherwise, they are also called as control plane. So you have one layer at the bottom, and then you have another layer on top of it, which is some sort of container orchestration. And in most cases, it is going to be some sort of Kubernetes, whether self-managed or cloud provider managed Kubernetes. Again, the Kubernetes layer comes with its own set of APIs, and it can be used to spin and provision and manage the resources within that layer, which is basically in the world of Kubernetes, it is called as kind. So your pods, your namespaces, your containers, things like those. And on top of it, now you could have service mesh layer as well. Now this is the layer which is getting extremely popular. If your applications have been designed with microservices architecture in mind and you want zero trust networking and hyper scalability, you would have gone for this layer too. Service mesh layer is above Kubernetes layer mostly. Now, service mesh layer comes with its own set of APIs too, right? And you can actually manage provisioning, deployment, many other processes for service meshes as well. Now, each of these layers now have their own attack surface. So the modern cloud architecture actually presents more attack surfaces. Having said so, because of these powerful APIs, the good guys can do good things, the bad guys can also do bad things. So each of these layers now have to be monitored. And also security has to be enforced, hardening has to be done, but it has to be done in a uniform manner. The moment you will start pushing point solutions for such a problem, that's where security teams face the challenge. We have a platform which actually allows you to monitor all of these layers in a very, very uniform way. That's first. Second, because of the advent of APIs, hyperautomation technologies like infrastructure as code have emerged in the last 5 years. But infrastructure as code on one side allows the DevOps teams to go ahead and provision your cloud environments rapidly, allows you to adopt agile processes, codifies your cloud deployment processes, but it comes with its own set of opportunities and its own set of problems. The first problem that it comes with, it is polyglot in nature. What that means is that today, the way industry is growing, for each layer, you have different infrastructure as code. For the bottom layer, you could have Terraform, which is cloud neutral. And then you can have CFD for AWS, you can have ARM for Azure, you can have GDM templates for Google, and others as well. Likewise, for Kubernetes, you could have hemp charts, customized templates, Kubernetes YAML 5, and a few types. And for service mesh, also, you have different types of infrastructure as code. You can use OpenFast YAML to deploy your service mesh and serverless layers on top of it, or you could use HTO console Linkerd configuration files to deploy them. Now, this is where infrastructure as code becomes difficult, but it comes with a big opportunity as well. You can enforce your governance and your policies ahead of time if you want to. But then, because of the polyglot nature of infrastructure as code, one big problem that industry is facing is fragmented governance. That's the second problem that our platform solves. We ingest all different types of infrastructure as code, create correlation between the code and the running resources that you have in your cloud. and then we build the context on top of it in a uniform manner. We use OPA framework internally to deliver policy as code. So you can actually deliver policy as code in a uniform way across all your infrastructure as code. That's the second problem. And the third issue that we address is the issue of drifts. Now that you have infrastructure as code, idea is to push immutability through infrastructure as code, always use infrastructure as code for change management. That doesn't happen always, right? You have to make changes directly into the cloud. That's where the drifts come in. We detect those drifts, we identify and contextualize them by applying policy onto it. If the drift is causing a risk, you can generate remediation as code using a platform. The remediation as code that we generate is shipped directly to the original developer, and then the developer is able to basically consume that code using GitOps processes like pull request, right? So this is how the problems are addressed, and this is what is your immutable infrastructure. I'll just quickly pass that slide. This is how the platform works. So basically, we have a typical DevOps or cloud provisioning lifecycle here on this slide. On the left-hand side, you have the developer writing code using source code management tools to manage the code. In the middle, you have CI/CD pipeline, which is constantly pulling that code and provisioning the cloud. On the right-hand side, you have the finished product, which is cloud. And at the bottom, you have our platform. Now, we provide various different integration capabilities for different stages. For the pre-commit or the design time, we have CLI-based tooling, we have ID plugins, we also have SCM integrations, the source code management tools integration like GitHub and Bitbucket. Using all these capabilities, the developers can perform early scanning of infrastructure as code, determine the violations. The platform comes with 1,800 plus policies out of the box. The policies are written in Rego language, which is a default language for OPA framework. Now, OPA being a CNCF project, it pretty much has become de facto standard for doing policy as code. But we generate remediation as code immediately as well, which is what helps developers kind of fix the problems at the source itself. The next stage is your pre-deployment or CI/CD stage. This is where our plugins come in handy. Our plugins are able to allow you to enforce policies and behave as guardrail. And then you can also gatekeep by actually enforcing your processes to demote or promote based on the policy failures. Again, you can run this in monitor or warning mode. You can also run it in enforce mode as well. Now, before the cloud is built, assuming that all the processes are followed, all the policies are enforced, when the cloud is born at time T0, this is where we take the whole application and the industry to next level. The traditional CSPM products who have been actually scanning your runtime environments, they are not able to build enough context. Now, by this stage, we have already built a lot of context of your infrastructure by studying and recording a lot of data from your infrastructure as code. But at time T0, we scan your runtime environment and we reverse engineer your runtime environment. Mind you, we still require just read-only permissions. We read all the configurations that are there in your cloud across all layers. And we also read all the relationships that exist between different resources. As an example, if you have EC2 instance, you have S3 buckets, and you have many other resources, we read relationships between them as well. And we record all those relationships in an intermediate format, which we call it as cloud as code, which is basically a codified representation of the cloud that is running. When we do that, we create the known good configuration or a baseline. Now, at this time, let's say somebody made a change, whether an attacker or a legitimate user. We are continuously scanning the cloud. We again create CSE version v1, and we make the comparison between the last version. This comparison results in drifts, if there are any, and the drifts then are analyzed based on the policies that you might have selected. If a drift is violating a policy, we generate remediation as code, check that code in a temporary repository, and raise the pull request against the main repository, assign that pull request to the developer. So we now have enabled developers by 70 to 80% in the remediation process. All what they have to do is now review the remediation as code that we are generating so that there is check and balance as well. Of course, we can automate.
Right. Now, us old guys, T0 is the golden image. And T1 is the file integrity check that realized that something changed in the golden image. You're doing this across the entire cloud infrastructure, creating these golden images and looking for changes to that image over time.
Absolutely. but the only difference is we're doing it in modern ways. So the
Right.
thought is still the old school. What we are doing is we are codifying your golden images and representing them as code,
Mm.
so that not only we can do comparisons between the configurations, but the codified representation, which contains a lot of graph relationships, allow us to determine relationships between each asset that you're running in your cloud. Those relationships are the one which attackers are also trying to determine when they first penetrate into your environment,
Mhm.
pivot to do lateral movement. We are able to determine those relationships ahead of time, and
Right.
therefore we are able to predict breach paths as well.
So looking for the misconfiguration that allows access to the S3 bucket to leak the data out kind of
Absolutely.
scenario.
Right. Capital One scenario. Yeah,
Yeah.
absolutely. So these are the slides. Let's jump right into the demo now. Now, this is our platform. I'll quickly showcase a couple of personas. So our platform is used usually by three personas. You have security, DevOps, and your typical infrastructure as code developer, right? Assuming the developer is on the left-hand side, this is the developer's workspace. And on the right-hand side, we have our platform, right? So the way things work is that if I were to quickly showcase, I have checked out some Terraform code that I'm supposed to be writing as a developer. The intention is I want to spin a VPC in AWS, which is going to have a bunch of EC2 instances, some S3 buckets, and some other resources, right? Now, as a developer, when I'm writing the code, I need to be able to check this code and also assess this code from security point of view. So what happens with our platform is our platform has a UI construct, which is called as environment. Environment is a way how you scope and create your assessments. So if I were to click on this new environment button and just call it sample. So the way environments are created, you connect with your AWS, Azure, or GCP cloud environments using read-only permissions. Once you've done that, you can mention what repositories you're going to make it part of, and then you can select your policies and then just call it finish. So I have a sample environment that I have already created, AWS custom demo. I'll go and edit this. You'll notice I'm connected to AWS in a particular region, and I've added a role ARN, which is a read-only role ARN. So next, I'm connected with Bitbucket right now. From infrastructure as code point of view, I can connect with many other SCM providers. Once I'm connected with Bitbucket, now here, I go and select my repositories. These are the repositories which will hold infrastructure as code. Once I've done that, I can also go ahead and understand whether I want to do deep scanning or I want to do linear scan. Deep scanning allows us to partially execute the code and perform the scan on the result of it, right?
Mm.
So once you've selected your repositories, select your policies. Policies are arranged in policy PaC. Select your policies here, and then you just say next and save. Now your environment is created.
Now, you talked about out-of-the-box policies. I assume there's also some customization if you want to create some custom rules in your policy as well?
Absolutely. So we have a very good open source project called TerraScan, which is great for the community to learn how policy as code works. Very good tool to also assess your infrastructure as code. Doesn't come with all the platform capabilities, but a very good tool. We've open sourced around 500 plus policies here. Policies work exactly the same. The community is contributing back policies as well. So if I were to quickly show you a policy here, this is a policy which checks whether you have a particular service open to internet or not. Very easy to write policies, Rego language. One big advantage that comes with it is deterministic value-based value matching. There is no guesswork here. There's no regular expression. There's no pattern, right, that we're matching.
Mm.
Anybody who wants to write a custom policy, just come, code it here, check it in, and the platform will be able to pick up your custom policies. Very easy to write policies against any cloud object. It could be Kubernetes. It could be any of the resources from existing cloud providers. As a quick example, if I were to just show you configure scan here, these are the number of resources that are found in AWS, right? You can you can write a policy for any of these resources. All what you have to do is just write a quick policy, select your object. I've selected security group as an object here. You can select Kinesis and just go ahead, select the parameters, select your operator, select your values. Your policies are written very, very easily, right? So once your environment is ready, now you can provide the developers the capability to scan their code, and the results of those scans are going to be shipped to the platform. How it is done? So the developers can download either a CLI, or they can also integrate using our CLI, which is available in each marketplace in IDEs, as well as on different marketplaces like PaC as well as Brew. So I've already pre-downloaded the CLI and just download the config file as well. Config file has the details about how to talk to a platform. So if I do cat config, you can see there's an address of the server where the platform is running, and then internal name of the environment. There is an API key, and there's a repository name here, right? Now, as a developer, all what I have to do is I have this code checked out here. If I just go ahead and run a quick scan here. So I've downloaded my CLI. This is my scan here. So if I just press enter here, the CLI is going to perform a quick scan on the developer's console. This can be done in IDE. This can also be integrated with a CI/CD plugin. The results will be available both to the developer as well as they'll be sent to the platform. I just refresh the platform, I would have received those results. Sorry about that. Fine. So if I go to resources, I'm seeing these are the number of resources that are being currently managed by the developer in infrastructure's code. I'll go to security group. And if I just open up any security group here, let's say this one, I see that some issues were reported. On the ISC side, I click on this link, it directly takes me to the piece of code which has the problem. So it says SSH port actually is open to internet here. It's been reported here. Now, it is also reporting that this problem does not exist in actually the cloud environment, right? Which is being scanned because I'm also connected with the cloud. If I go to configurations here, this is where you see cloud as code. On the right-hand side, you can see the codified representation of your cloud resource. On the left-hand side, you are seeing the Terraform code for the same resource, right? This is where we detect drifts. So when we do these comparisons, we are able to see there are drifts between ISC and the cloud. And the platform, when it is set up, first time when we are setting up the platform, we allow the customers to choose what kind of remediation preferences they have, just like how you are setting up your iPad. So once the platform is set up, against each policy, you can provide what kind of remediation preference you have. So let's say that I had the remediation preference available from the customer, that if you find any services open to internet for a given VPC, please block them by this CIDR block, right? So then the system goes ahead, creates a pull request for such a thing. So let's say this was my remediation preference, which we call it a secure value. System is going to generate this code, which is basically remediating the problem. Now at this time, I can just assign this code to any developer or the development team. This code can be delivered as a pull request to the developer using Slack, Jira, email notifications, and many other notification systems. Essentially what we're doing, we will check the code in a temporary repository and raise the pull request against the main branch, which is what we are scanning. And again, we don't require any write permissions on the main branch. We just need to check the code in a temporary repository. So if I press the create pull request button, of course, the platform would have automatically generated this pull request. I'm slowing things down to demonstrate the capability. Now, as a developer, clear this. If I go ahead and try and do a pull on this one, this repository that I'm working upon, I would see that there is a pull request which is waiting from Accurix, right? Which is trying to remediate. Now, I would have also received this in an email or a Slack message. So if I go back to my email and just open this up, okay, I see I've got an email just 0 minutes ago. It says this is auto remediation by Accurix. We detected there was a CIDR block that was open to internet, which trying to close it. Here is a pull request. I click on that as a developer. I get to see this code here. Now, when I see this code as a developer, I can decline it if I don't like it for whatever reason, or I can just approve it and press merge. When I merge it, the system automatically determines that an issue has been merged. And that happens because if I go to repository settings and webhooks, you would notice that I'm connected with the platform through webhook. I'll go to view request. Just a couple of seconds ago, a new webhook was raised, right? This would have sent information to the platform that a new check-in has happened. Of course, a new scan should get triggered here, but I'm going to just manually trigger as well so that we are able to not mess up with things. The scans happen periodically as well as they are event driven. So once that happens, now if I go to analyze here and check port 22 open to internet, you will see this problem is found only in cloud now, not in IAC. The IAC issue is gone and solved, right? So if I go to dashboard here and go to configuration drifts, security group, open up here, port 22 is now closed in the code.
Fixed. Yeah.
So that's how your drift as code, your remediation as code, and policy as code works. And if we have a little bit more time, I can quickly show you some advanced breach paths as well. Do you think we have time, Matt?
Yeah, there's a couple minutes left. I'd love you to show the visualization real quick if you can, because I think it's super powerful to see all these components visualized.
Let's do the visualization really quick. Now, as I explained to you, we read all the relationships as well that are available between different codified structures. Go to topology view. This is how the visualization looks like when actually we are performing the analysis. I can also show you a little bit more simpler one. The visualizations are able to show you network topologies as well as trust boundaries, right? And then when we populate all the violations which are detected on them, we use MITRE's attack framework as well as kill chain to map the TTPs to the violations and to the relationships that we have discovered. So how the attacker can actually move in your environment through the attack graph. So we can now determine what are the reconnaissance capabilities, what are the delivery capabilities in this example. We'll go to threat model here. I have more examples here of reconnaissance, delivery, exploitation, command and control. Now, what happens with these visualizations is that the security teams can set up policies that, tell me what are the reconnaissance capabilities and go ahead and remediate them. Now, the pull request is going to generate all those remediations. The developers will just receive the code. They don't have to understand what is threat intelligence, what is threat modeling. Mm-hmm. They'll be fixing threats all of a sudden now, but just not fixing violations, right?
Yeah, it really helps with the context because the developer doesn't have to understand why. If they're handed the code and it remediates the issue, it removes some of that awareness friction that's always there with the development team.
Yep.
That's awesome. I love the visualizations to be able to look at your threat model and see where the different threats are, and then you give them the ability to just create the remediation as code. It's such a great visualization.
And then we also have some advanced capabilities as well, where we are actually able to show you what happens if one asset gets compromised. How many more assets can it take down of itself? This is what we call it as conflict blast radius. For each asset that we determine it has violations, you can figure out that it is connected to how many more assets by identity, access, network, or privilege relationship, right? It may have an IAM role, which is actually proliferating access to other resources as well, a given asset. So that these are some of the advanced capabilities which are possible to be achieved using infrastructure as code.
That's awesome. Thank you so much for demoing Accurix today.
Absolutely, pleasure. Thanks for having me, Matt.
After this session, you will be redirected to the Knowledge Center. Please feel free to download any assets. And if anyone wants to ask questions, please join our Discord server and get connected directly with Accurix. You can also visit securityweekly.com/Accurix to learn more. Thank you for joining us.